Okay. Hello everyone. I'm Gautam, and I'll graduate from BITS in a month, and I'm a founder. Yeah, founder currently building my own startup. So my 6 weeks at residency, I built an agentic system focused on credit assessment and checking for defaults in the credit risk scenario. So my talk is, so everyone has given a technical talk, and there are a lot of technicalities. My talk is basically is based on two things. How do we approach a research problem? If you have any problem, how do we research on? And second part would be, and from the first part we will get many in general learnings, and second part would be mainly focused on the technicalities about how this agentic system forecast works. So, yeah, it was February. I was planning to go to Georgia Tech as a visiting research student, but then I had this thing that let's not go there, and I'll be working on some like very normal problem, a research problem. Let's be in India and build something. And the answer to that was time series forecasting, because I'm an CS plus economics grad. I've worked on time series a lot on RIMA models and all, and I wanted to explore more on time series foundational models, and I wanted to build things around it. So yeah, so my like the whole presentation is in terms of learnings. So first is, I would say, believe in yourself, because like I tried not going to Georgia Tech and being here, and I am glad that I did take that decision and got an opportunity to work at Lost Funk. And yeah, there was a meme here, but yeah, it's not working. And second learning is DM, cold DM anyone, shoot your shot. I'm DM'd Paras to join residency, and then I had a interview call next day. I was set to leave in 10 days. I had my visa, but yeah, then I came here. So yes, second learning is DM and yeah, shoot your shot. But yeah, why this problem? How credit assessment? How I came to this problem was yeah. So I have a business kind of mind, and it's always around equity, stocks, and all. And similarly, I had this thing: why not do it for markets, right? But markets are challenging; they are ahead of us. And what Benny was building, right? It's challenging to build a similar kind of thing, but we can do this in when you have some foundation in coming years. But I feel today is not the time where we can try to forecast and build equities with the context that we have. So what's the closest market or alternative? That was banks or the financial institutions. They needed this credit assessment problem. They needed to model the user. How do they see if a person would default in coming years? What are the different factors that involves the default risk behavior of a particular customer? So this is I'm just building up the problem. By this problem, this is a simple scenario workflow where you review the application, then check for financial health, ask for credit references, then calculate the score and get the approvals. And what I was trying to do is to create this forecasting system for the probability distribution function of credit default happening. And this is what actually people wanted. But in and that comes after the fifth step in our whole workflow. But when I after talking to different people, I I got to know in the industry, before you analyze or forecast the probability function, you first have to onboard the customer. And the first problem that you have in onboarding is whether the person is credit worthy or not. So this is the first problem. I came with the intention to at the residency to forecast the distribution function. While after talking to people, I thought, like, let's solve the first problem, And yeah, and next, and then go to the more challenging part, or what where there is a need for forecasting. So third, learning. Let's think step by step. Yeah, COT. Look what is needed. Talk to people. What is needed. Solve the problems in a way, in a system. So first, we try to solve the creditworthiness problem, then the forecasting problem. Now, if we see the existing methods that are there in used by the different financial institutions, already there is basically stats, ARIMA models or some different models. If we talk about forecasting, and if we talk about creditworthiness, it's about it's manual work. People are there, they'll approve, and they'll just check your financial health, credit score. So the whole process is very manual, or it's driven by statistics. What are the disadvantages? First, the limited, we have a lot of data, and using this manual process, we are limiting ourselves of not using data that can be used to probably get more probably be better at decision making. Second, there are biasness and obviously fairness issues. You are good with some people at the institution, they'll approve something for you. You are not, you have a beef, they'll not do. So all these bias issues are there. There's lack of transparency, obviously, and all the statistics model fail when you deploy in the market, because there's no context. Market changes a lot. Market in general, the world changes a lot. You cannot model the world, and based on only on historical data, the statistical model will fail. So yes, like my solution, or the aha moment where I started this problem, where I started my research, was beating. So first, obviously, the main question is beating the standard models and traditional models. If I'm not performing better than them, what I'm doing, like there's no use of this system. Second is, are LLMs capable of the financial reasoning of what we say? If we say about reasoning, it's about general reasoning. But if we talk about financial reasoning, can they reason whether to give loan or some in other, like in many use cases, like let's say in equities, in markets, how do the LLMs perform? And yeah, so my thing is, when in doubt, always rely on the real world. How do you do in the real world scenario? And that's what I did. In real world, it's a system, it's an hierarchy where you come at the institution or the bank, you give your data, your application is processed. So it's a hierarchy. So I thought, why can't we just replace that hierarchy with agents? Why not we have different agents replacing humans, and using that as a system, and probably we'll get similar results, or maybe we are better than them. So I try to mimic what we do in our real life. This now comes on to like, this is how I built my research problem, and at the end I try to solve three research questions. First was, we create a multi-agent system in credit assessment, which was not created before. There were not any agentic system was not trying to solve this problem. So we are trying to see if this works or not. Second is this game theory perspective. If you don't have a theoretical backing for your own problem, you're probably people won't try to believe you that this is working. So you should have some theoretical background why this works or why this is not working, anything. And third is analysis of biases in LLMs in this particular scenario. And these were the three research questions we boiled down to. Next part of research is start with some basic evaluation. So this is RLMs good at credit assessment. This is zero shot. I had data, I asked questions, and using two models, I got some metrics of accuracy, precision, recall, fit score. I got the metrics, just basic initial prompting about how things were, just basic data, and if this is working or not. Yeah, our LLM is good at credit assessment. This is baseline for us. This is how I started. This becomes our baseline. And second thing is, what if there are multiple models? Let's say there is single agent performing multiple tasks, or there are multiple models performing different tasks, and then we combine all of them using some decision orchestrator. This also becomes one of our ablations, or what we say, one of our baselines, that this can also work. So these are some accuracies, and yeah, I feel these are very bad numbers, but good for baselines. Yeah. Now, after initial experiments are done, we know what our baselines is, what the initial numbers are. We try to come up with our own architecture. Yeah, I mean, who can be a better architecture than him? So, yeah. So, we start with, as I mentioned in the initial presentation, that we start with some hierarchical. We try to mimic the original. Process, how it is done in real life, and we just try to do an agentic system. At layer one, we have three agents, which are data analyzer, contextualizer, and feature engineer. Data analyzer is basically, you give unstructured data, it will give you a structured data, and in contextualizer, it creates a user persona. As people try to create a user persona, or they have some perspective about a person, this is what we are doing in this agent. And third is feature engineer. You have some data, you have some metrics. Now you try to create more metrics using those numbers. Let's say debt to income ratio, if you have income, or dependency ratio. All these ratios you try to create, and basically you are expanding your data set. This is what layer one is doing, and we get layer one result, and we now go to the second layer of our agentic system. In this system, what we are doing is, so I was working on, so where I got this idea is, I was working on some, there's a DeepMind paper for prompt optimization called OPRO, where they were doing not contrastive learning, but they are showing contrastive prompts, that this is a bad prompt, this is a good prompt, and now you try to give a better prompt. So similarly, if we do a contrastive learning, so this is not learning as such, but a contrastive display of two things. One is reward modeling and one is risk modeling. Our risk modeler, I would say, is divided into three more agents that are basically income. So these are just focusing on specific type of functions. First is income or stability, then second is debt, and third would be risk modeler, which is whether it is feasible for the bank to give or not. So this is our second layer, where there is a contrastive learning kind of thing, where we are doing reward assessment and risk assessment. And our layer three, this output goes to our optimizer, which tries to optimize with the given risks and rewards. And then when deployed in original systems, you would need regulatory or compliance agents. This is an optional agent, since I had a data set where you cannot add this, or this won't make any sense. That's why it's an optional agent in our system. And then finally you will have all the aggregated data, all the aggregated results, and there would be a decision orchestrator that would be taking decisions. Learning for small techniques can make you strong. One of the main problems that I was facing is I wasn't getting structured outputs, or if I was getting output from any particular agent or all, there are a lot of formatting issues. Like, if you want to extract a particular in a JSON format, if you want to extract a particular attribute or a key, it's difficult. So these are very little things that make you efficient as a researcher. You can use VLM structured outputs, where you can define that this is the format of my output, and this should be given. So yeah, our multi-agent results are better than the baselines, and this works actually. And if you see the GPT-4o and O3 mini, which is a combination, this works best, because GPT-4o was used for all the naive tasks, and for the decision orchestrator and optimizer, we had a O3 mini, because it's a reasoning model performing better and giving better results. But this was basically a hierarchical structure, and what then we tried to do is try to make it async and add tools. So we added tools to calculate the different formulas in layer one initial steps. We also added the reward risk reward optimizer. So it turns out it's better than the earlier methods, and there is, and like the improvement is lot from 60 to 72.2, uh, and there is still scope for improvement when you try to make or deploy in real-time scenario. I also tried to do human annotation. So I this site called Prolific, where you can get human annotation. I spent some bucks and tried to get it annotated. It was a particular German data set. I chose German financial people who would annotate the data. Some of the samples, it was a subsample of the whole data set, and which gave us better accuracies or almost the same accuracies. So 75.88, which means that there's still improvement, need for improvement, and we want to go from what we achieved like 70 to 73 to 75.88, which is human annotated results. The hardest problem that which remains unsolved actually, which I faced, is lack of data. Lack of data in financial tasks is like it's very bad. You need synthetic data. Probably you need to have some collaborations to get data, and then you can probably see if your things are working or not. As previously in one of the talks, someone mentioned that research papers are working fine to publish, but when you try to deploy, this won't work. That's why we need data to check if this works at scale or not. One aspect of the presentation is signals as well. So I started with the second contribution of theoretical backing. It's a signaling game theory. It's when you have a hierarchical agentic system. One of the agent is trying to, so there's sender and there's a receiver. Sender is trying to give signals. There are two possible signals. It's a private information. It tries to give a signal to the next layer of your agents, and then they can probably, based on the input, they can try to make the decision. And this input is basically the signal which you get from the receiver and from the sender, sorry, and the receiver takes the signal and appropriately would take the decision, and we will get a payoff. At the end, it's a game theory framework, and at the end it will get a payoff matrix. So third contribution, LMs are biased. We see if there, so to see if there's biases, we had a data set where there was a gender. We saw when there is male data points, it gives 65 accuracy, and if you change male to female, the accuracy from 65 reduced to 58, which is considerable. And when there's no gender, it changes from 58 to 51. So this shows that how important gender is when you are which should not be the case, but how important it is for the LLM while predicting the accuracies. We also did for ethnicity, just for a more comprehensive results, and we saw that when you add ethnicity, ground truth is the highest, gives us the highest result, and Asian ethnicity has the lowest accuracy. So learning 5, green flags, red flags, and beige moments. You just don't see about this is good, this is better accuracy, or there's biases biases exist or not. You should also see for different things what is causing these biases, which are counter biases, basically other factors are affecting the final result, probably income or probably other things which are coupled with gender. So that's the learning 5, not just the results, but also see why this is happening. What's next? Using this agentic framework, you can try to do in different topologies: mesh, grid, torus, and now after you have solved the first problem, you go to the second problem of forecasting the probability distribution function. And yeah, you can make these agents self-evolving as well, as alpha evolve is there. which shows promising results. I'm just going through future work because time is less. And can we actually deploy this? Yes, we talked with a YC startup and Series B. Sorry, Series B. It's a Italy second tier league. So we talked to this startups. They are ready or they are willing to try our system. And yeah, post that like we can get how these systems work in real life. Learning six network and help each other. Both of them were given from Lost Funk. Thank you, Shruti, Abhishek, for this connections. And result paper accepted at a workshop. I wanted to submit to EMLP as well, but yeah, due to some delays, could not. Learning 7, last learning probably hard work and skills. Guilfoyle, my favorite character. Yeah, so nothing can be done without hard work. And yeah, thank you so much. Thank you.